No, this thing isn't a scary weapon. It's actually the wing swing mechanism for the F14, the normal size F14 that's behind me here. Welcome guys to video 2 in the Skymaster F14 series. This is the 1775 scale, 1/8 scale aircraft, and we're rocking and rolling in this thing. Previous video, we got all of our stuff organized, laid out. We got the fuselage disassembled, and now it's time to start working away on things and moving forward. So thanks guys for tuning in. Let's get busy. So previous video, we had just finished up taking all of the stuff out of the rear part of the fuselage. So that's done. Next thing we need to do is to get our operational tail hook created. So first thing we need to do is come up with a hatch to access our servo that we're going to mount in this piece right here. Now this is going to get glued onto the underside of the fuselage. As it sits right now, the stock system, the hook rotates side to side. So we do end up gluing this piece solid, and it's a great system that we used previously on this, so we'll repeat the exact same thing. So I'm gonna take my razor saw and we'll just cut an access hatch here to allow us to install our servo. So one of the little secrets to cutting nice straight lines with the razor saw is having a straight edge of some kind. So this is quite helpful. The access hatch can be fairly large because you don't see it on the underside of the aircraft. And we want to make sure we've got enough room to be able to work inside the fuselage. So that gives us a nice straight line. We'll do the exact same thing on the other portions. All right, so we got a nice access hatch cut here. We do have the big glue glob there, or globule, or whatever you want to call it, but we can Dremel that out, no problem. We've got our piece here, which we will screw back into place when we're done. So this is kind of step number 1 for this guy. All right, so if you look at the layout here and dimensions and stuff, so if we level off the mount here for the pod, that is where the tail hook is going to sit in its upward position. And then as it comes down, doesn't need to move that much. So that's basically our movement right there. So if we look at the actual arm, we need to move about 10 millimeters in and out. So it's a pretty short linkage that we're going to be putting on there. We're going to use a MKS HV69 servo for this. That's what we used on our previous one. So I'll go grab one of those servos. All right, so the HV69 servo from MKS, great little servo for this type of application. As far as the power goes, we're going to be running it at 8.4 volts. So essentially we've got about 10 kgs, 10 kilograms of force from that little guy. So works very well. So that is pretty much how it operates, like this. What I do is I put a 3mm Allen bolt coming through here, and then we can just put a big ball joint on top of that, and that allows the ball joint to move and flex and everything up here. And then we just have our servo arm mounted right there, which works out very well. So anyways, this is how we get everything set up. So not overly complicated, and I think last time I ended up using these guys to mount it because then I just created some U-blocks that fit around those guys. So it was a pretty easy mounting system. All right, so getting our servo set up here on the tail hook. So in this position, it's going to be the up position, and our linkage is going to come straight like that. So the point of doing it like this is so it's locked out when it is in the up position. So when it's up, there's no force on the servo, and it's not going to drop down when the power is off. And then going down, we've got the option of adjusting our servo limit in the down position. So we'll probably end up using that inside hole right there. So now we need to get our the rest of the tail hook set up and get our mounts figured out here as well. All right, so we've got one of our heavy duty KST servo arms installed. Now we're using a plastic arm because we want to have some point to give. So if there happens to be some contact or something with the ground or whatever, we want something to give in the system, which is going to be that plastic servo arm. And then we took some aircraft ply here and made some mounts for the servo. So those get glued into the pod, and then our servo can get screwed down to those mounts. So that's our mounting system all sorted out. All right, so we got all of our plan laid out here for the operational tail hook. So we've taken out the stock screw from the pivot here and installed a big 3mm screw. So this will get cut off, but it allows us the opportunity to put a nut, maybe a spacer if we need it. Then we can put a 3mm ball joint on there as well. So we've got freedom here to be able to do what we need to do. And then there's lots of room in this guy when it retracts. So that's step number one for that portion. Next thing I need to do is figure out our ball joint on this side. So I could run one of these guys, the 3mm ones. They're a little large for this. So if I have a smaller one that'll use a 3mm arm, that's what we're going to end up using. All right, so getting our final geometry done up here. We've got our servo mounted, tacked in place. So we've just tacked that with some CA. We've got it in the lock position. And what I do is take this straight edge of the mat, line this up. We'll get our end of our tail hook installed. And I just realized that that's upside down. So I'll have to flip that around. Huh. Stuff happens. Anyways, pretty easy to flip that around, and of course we'll flip the other side around as well. But you can see here we've got our two ball joints. So what I'll do is I'll take a 3mm rod. We'll kind of get it sized up for that, but we need to flip that around first. All right, so we got everything queued up here. We're pretty much adjusted, I think. We'll have to do our final adjustment on linkage length with this installed in the fuselage, but if we line this up again on the mat here, we're about 1/4 of an inch from the hook touching the mat, so that'll get us in the right wheelhouse. So if we want to check out the action here, I've got full flaps on, and I'm going to push my button on the back, and there's tail hook. So pretty cool stuff. Works really well. The system looks good. So again, we're mechanically locked in the up position. So when this is airplane's being transported, when it's just sitting there, there is zero force on the servo, and we can confirm that with the amperage on our screen as well too. So now we need to make a cover plate cover or mounts for the cover. So we're just going to put some thin ply in the back here so we can screw that cover plate on, and we will make a little exit at some portion right here, probably skewed towards the front, for our servo lead to come out and go into the fuselage. All right, so we got our linkage all adjusted. We've got everything set up here to install. So right now with this fastened, we're just contacting the fuselage, and of course the servo is locked out. So we are going to glue the pod here to the fuselage, and that's going to be a great setup. The servo lead's just coming through the fuselage, and then we'll run our extension all the way forward as well too. So we'll get this guy glued in place, and then we'll be able to flip this guy back over. And continuing with our moving forward, we are using some BVM heat shield, and we're going to install 3 coats on the inside of the tail cones. So a couple of the reasons for that. Number one is it works as a good reflector to really make the Afterburner lights from Unilight pop. And the other thing, of course, is it provides heat protection to the turkey feathers. All right, guys, so moving on to tanks, we're getting ready to install our bung fittings for the tank. So I've drilled the main tank out here with our step drill bit. And generally what happens with the Kevlar tanks is you get all the fraying. That's what the Kevlar tanks are designed to do. So what I'll do in this case is drill up my hole to the right size, take some thin CA and you want to soak all of these fibers in thin CA. Usually they'll kick off by themselves. You'll see them start to smoke, but we'll get these all covered in thin CA. And this basically makes the fibers brittle again. We'll spray it with a little bit of kicker. That's going to kick off. You can see it going crazy there. And then what we can do, once that's hard and rigid again, then you come back with your drill bit one more time. And you drill out that hole. So now we are the correct size. And then take an X-Acto blade and we're just going to go around the perimeter and chop off the fibers. There. So still have to do that one, of course, but now what we're left with is a nice opening in the tank that doesn't have all the fraying Kevlar material floating around. Then what I'll do is I'll just take my Dremel and I'll just go around the edge to make some gripping surface before we glue these guys in. And also what I'll do is with a fitting like this, which is a smooth tank fitting, there's no ridge or anything, I'll take my Dremel and just roughen this guy up all the way around, again to create a nice gluing surface before we high-sol those in place. All right, so we got everything prepped and ready to install. So we've sanded around the perimeter of all of our holes. We have sanded around the perimeter of the bung fitting, and our vent fittings those holes have been done as well too. So when we do these guys, we are basically just getting some high-sol installed around the fitting, just around the perimeter, and then just push it in place. Often if you get a nice tight fit, it will just hold itself in there. So there's really not a whole lot to do. And sometimes if it's a loose fit, then you'll want to use some masking tape and get them held down. So we'll see how this works out. And I don't generally like to tool these fittings once they're installed. So meaning that I don't like to go back with my finger and try and smooth it out, because it doesn't usually work out that well. There we go. So I guess if you wanted to, you could tool around there. I don't know. I don't really like to do that. I like to leave the bubble of high-sol, but let's, I guess, tool these ones. Because the bung fitting doesn't fit around the edge, I guess it's really not a big deal. So there we go. So one installed, we're going to do all the other ones. And when I install the vent fittings, generally what I'll do is avoid the first couple threads. So just like that. And we're pretty much going to sink these things down all the way. So I have already threaded these guys in, so they kind of created their own threads on the tank. And that's a nice thing to do, so when you get to this point, you're not messing around with the fittings. Now I do predetermine which direction I'll be running these, so I'm I'm going to have these guys split down and they'll go backwards to the other tanks. So that's the vent fitting installed. I'm not going to tool those guys. I'll just leave it as a big glob, and that's good. So we'll repeat this on all the other tanks, and I think that's good. We don't have to tape that guy down, so awesome. All right, so with all of our bung fittings installed in the tanks, the next thing to do is our fuel fittings in our caps. So all you need to do with the fuel fittings is red Loctite. Works very well and seals everything up very nicely. So you don't need to go anything beyond that. You don't need to use thread sealer or anything like that. So we'll just get those guys clipped in, and that's basically the caps. All right, so we've serviced our main door cylinders, and I just filled up our closed side, the yellow side, with air on both sets of doors, and those guys are doing their thing. So we're gonna leave those be, and we'll come back in about an hour and do the same thing. Now, one thing I'll show you on the air brake that I do is once I'm happy with everything and we know that everything's good, I put a little drop of rubberized CA on the tube to nipple joint. And I've started doing that just to help hold everything in place. So there's an example of it right there. We've done the air brake, and that helps to hold the air lines in place as well. Now, I generally don't like to use safety wire on the airlines. I find it's not a big enough area around that it works really well, especially if you want to do 2 rotations, which is what you should be doing. So I prefer to use the rubberized CA, carbon and rubber toughened IC2000. So that's the stuff right here. Works very well for situations like that. So that's why we've got that in our arsenal. So of course we flip the fuselage back over. Our tail hook is all set up there and good to go. So I can feel inside here, we've got our lead coming from our servo, and we're gonna get our extension done up for that in a little bit, but we're gonna start working on the tail cones forward. So we need to kind of route wires carefully as we go through all this stuff. Now, just to cover what's in the back here, we've got our Afterburner lights. Very likely we'll put the controller for those guys right there. We've got both rudder servos. So those servos get mounted in the actual rudder itself. So we'll have a plug-in right in this area, and those plugins of course need to run forward for the wire. With our afterburner lights, there's going to be 2 leads from each afterburner running towards the controller. We've got our elevator servo here as well too. So that's kind of everything that's going on in the back end of this aircraft. And additionally, we've got our lights to deal with as well too. So on the rudder, we've got 2 lights to add on there as well. So quite a bit needs to run forward. We'll just do this in a sort of organized process. At planning time, and because we know where the central box is going, we can get our wires done up here. So I like to do my wires up, make them excessively long, and then we mark each end, and then I end up doing these ends, or the finished ends, once we're ready to plug them into the central box. So we've got 4 really long wires here. We go through quite a bit of this power box wire, that's why it's on the spool. And these wires are all for the rudders and horizontal stabs or elevators. And then we've got a little bit shorter one here for the tail hook. So I'm gonna get what I call our female ends installed on these guys, and then we will have the ability to run those towards the front of the aircraft as we use them. All right, I don't know if I've really shared this before, but this is kind of our organization for doing wire ends. So we've got our power box set up here. So the power box connector system comes in 4 different pieces to make all the different style of connectors. So if you're making a female, what I call a female connector, The process is pretty much the same thing. You just add 2 more components to the female connectors. So I'll get these guys ready and show you. Now, quite a few years ago, I did a detailed video on how to crimp wire ends or servo ends. So I won't go into the details, but this is the process. I don't know how many thousands of these I've done, but you do get pretty quick when you've done so many of them. Also helps to have everything organized like this. I used to just toss it all in one bin, and it was a bit of a pain because you're always fishing through, so having all of the pieces like this is quite nice. So then we take our connector. Now the only difference when we're doing the female connector is you flip the white and the blue around. Your red is always in the center. So that's that. We're going to give that a push. And then we take our pin system, push that in. Now the power box, I've noticed a bit of a difference in their items lately. So those tend to move a little bit more on the pins when you push them in. These are a little bit looser fit compared to how they used to be, but that's the female connector, all good to go. So we'll do the same thing on all 4 of these, then we'll label the other ends to have them labeled as the appropriate item. All right, so working on these Afterburner lights. So there's really no easy way to get them in the turkey feathers here, but there is an easy way. So they don't fit this way, they don't fit that way. So what you want to do is you want to squish the turkey feather without destroying it and sneak it on in there. So what I'll do is feed these guys through the same hole on each side, and they just sneak through, or at least they did on the other one. There we go. Now I found with the Unilite Afterburner rings, you want to be careful not to move that wire around too much. They are soldered to the board, so if you are too aggressive with them, they can come off. What I'll do once we glue these guys down is I'll put some aero epoxy or goop on them. So now what I do is just get them skewed towards the outside of the Afterburner ring, like that. And then we kind of split the difference with the wire. So the wire is right here and right there. So we're kind of splitting the distance to those holes. And the reason for that is to keep it, the wire is roughly the same length for when we put these guys together. So what I do now is I spot glue those guys into the turkey feather assembly and just use some CA to kind of get them stuck in place. We'll test fit them, and then if we're happy with them, we'll use some aero epoxy and glue them down in place. You don't need to do every single heat sink, but you want to make sure you're getting quite a few of those heat sinks to make sure they're glued and they're not going to go anywhere. All right, so that's what they look like when they're fit. Now, when you put these turkey feathers or tail cone sections on, you'll see that the inner former is shifted off to one side. So that's sort of an important step. And the reason that is important is your pipe comes straight back, and then there's a angle towards the outside of the aircraft or away from the center line of the aircraft right at the tip. So this is an example of the pipe. So if we have that pipe sitting like this, you can see the tail section there skews outwards. So what that relates to is the pipe is sitting over here, and then that angled piece comes like this. So you want to have the larger section towards the outside of the aircraft, not the inside. So those are ready to go. So what I'll do now is we'll get some aero epoxy mixed up and get these guys stuck in place. So we'll pull them off while we do that. All right, so we're using some West Systems 610 for this step. So this is it right there, the Vaseline-y looking stuff. And all we need to do now is essentially just go around and glue some of the heat sinks to the former. So nothing overly complicated, pretty straightforward stuff. So we'll go around and get all this done. Now there is a decent amount of space between the light and the pipe in most of this. You have to kind of skew this towards the larger side of the former because you don't want to interfere with the fastening screw, which is right there at the end of trusty bent screwdriver. So we kind of skewed that this way towards my hand, but you got to remember it's a double-walled pipe as well too, so the outer wall of that pipe really doesn't get that hot, and we still have a decent amount of space there as well too. So we'll go around, glue these guys, and we will leave them sit to cure. All right, so one of the challenges we had on the very first model that we did like this was the rudder setup. So we wanted to make all the rudder linkages internal, which we did previously, and that's a bit of a challenge. So I'll kind of explain how we did things previously here. So the rudder servo is quite inset in the vertical stab surface. So if you were to look at the outside, it's basically sitting like that. Now, one of the positives is that rudder servo is perpendicular to the hinge line of the rudder, so there's no funky geometries or anything going on there. That is basically the mounting plate line, just like that. So what happens is our servo sits in there like this, our rudder sits in there like that, and we actually take a portion of this section out to allow the ball joint to mount in here. Now there is a hunk of balsa in this area, so I can see it inside there. From memory, I think it comes out to about here. So what I did previously with this is add a plywood, aircraft plywood reinforcement in this area, and then we mounted our ball joint to that plywood like that. So I think that's probably how we're going to repeat this. It worked very well, and it was a successful way to do this setup. So looking inside here, there's a little bit of giveaways on where you want to mount things. So there's a little hole through the former work right here. That's where our arm comes through. And that means that our ball joint is going to come to this point right here. Now, you want to make sure that you're not using an arm because you won't have enough room. So in this case, we're going to use the MKS hubs. We're going to use the carbon arm, which is going to act just as a spacer. So that's just going to mount here. We're going to get rid of all of the carbon. And then our ball joint is actually going to get mounted to one of those holes right there. So it's going to be a very short arm movement. Now the F14 doesn't require a lot of rudder movement either. So, you know, you're basically like this as far as the movement goes. So if you track that pivot point right there, you're only moving maybe 1/4 of an inch. So that servo arm, when it turns on the servo, only needs to move that ball joint 1/4 of an inch total. So that's why you want to use a very short arm, or in this case the hub, with the ball joint mounted very close to the center of the servo. So that's kind of the overview on how we're going to do things. I'll try and show you guys the steps as we go through this, and that'll give you an idea if you're building one of these aircraft on how to do it. All right, so we got the plan figured out here. We've got the rudder pockets and everything opened up to allow the control linkages to pass through. We've got this section sanded out. So when I did this previously, I actually sanded out the entire bottom portion, which wasn't really needed because there's no balsa wood on that side. So the balsa wood's just on this side, which is fine. And we've got the leading edge of the rudder surface sanded out there as well too. So as far as positioning goes, that kind of gives you the overview of everything that's going on. Now we are doing an interesting setup here for the control linkages. So this is the servo arm, and we're really not using a servo arm, we're using this carbon spacer. So we've installed with Loctite the bottom 3 bolts, and this one might be backwards because this is our left side, but anyways, that one we'll just leave aside. For this guy here, this is our right surface, which is the one we're working on, and we will have one of our ball joints, this guy here, mounted with red Loctite right there. So that is the plan, and that gives us our movement. I just left these guys out because they may get in the way. So we'll see how that all pans out, but that is the plan. Now, before we can do anything else with the actual servo installation, we need to get our lights figured out. So the lights are pretty easy to mount or run through. There's a channel that comes all the way up to this point, but the challenge obviously is getting these lenses done. Now we do have that lens package, so we'll pull that lens out and we'll see what we need to do to get that mounted. So we will take our razor saw and cut this lens out. Now I know this lens is green, but both of them on the F14 are red. Light has been removed with our razor saw, which was pretty simple. And now we've got the cutout, which is all nicely shaped. So what we'll do now is we'll hold this guy up there and we'll just trace it out with fine line Sharpie, and that gives us our location to start sanding and cutting and getting rid of all the excess material to make our lens. And that's what the block looks like once we've got the lines traced. So now we just take this to the sander and we get rid of all the excess material, leaving the black lines, and then we'll shape it. Once we get the rough shape done, then we can work on the fine shapes. All right, and there's the lens all shaped. So just doing most of that by hand and getting it fit nicely all along the perimeter, and looks really good. So now what we'll do is we'll get the light out and we'll see how we can get the light fastened to the lens portion. Previously what I did, I kind of hollowed out the inside portion here so the light can sit right against the epoxy lens portion. So we'll pull the light out and we'll see how that's going to fit. All right, so this is the light that goes in the right vertical stab. And I think what I did previously was get this guy mounted into the actual stab itself first, but have a little bit of the LED sitting in that, that pocket. So I'll just take my Dremel and create a little pocket right here. So when this guy is sitting in there, it's nice and recessed. So and the other thing we'll do is we are going to get our line run to run that wire. Now from memory, I think this is pretty simple. There's a pocket underneath the servo, and that's why you need to get that servo mounted first, or not mount the servo first. So just a little bit of finagling and it made it through there no problem. So I will cut the end of this light off. So we want to make sure we leave it long enough to be able to fish down into this area and be able to plug in to the plug right here. So we'll just cut, I don't know, about a foot off of that light. And then now we'll feed that wire back through the rudder surface. So nice, pretty straightforward pathway through that guy. So all we'll do now is we'll get this guy mounted, and we will, like I said, leave a little bit of those ears kind of sticking out if needed, which I think we need to. So actually I don't think we need to do any sort of cutout with that guy if we have it sitting just like that. So what I'll do is I'm going to spot glue this with some CA, and then we'll put some shoe goop on there when we fasten the lens down, and that'll tie everything in together. So we're just going to have it recessed just like that. All right, so light has been spot glued in place. Now there's a couple different ways to finish off these epoxy lenses. So the way I prefer to do it is install clear coat on it. You could take the time to wet sand it and get it all smooth. The clear coat's just a nice quick way to do it, and it does fill in all those gaps as well too, and sanding marks and everything. So what I'll do in this case is get the lens glued in place with goop, and then we will just take some clear coat afterwards with like a paintbrush and paint the lens, and that makes it look beautiful and smooth. All right, and we've tack glued that in place, and now we'll just take our finger and clean up the goop. Now you don't necessarily need to do that because you can pull it off afterwards, but rather than taping this in place, that little drop of CA on the top just takes care of it all, and now we can leave that, that lens to cure. And if you take some kicker here and spray the lens, that's what it's going to look like when you put the clear coat on there. So, and we can also do some more shaping afterwards if desired, but that's basically the lens. All right, so we kind of have everything figured out here as far as the rudder and everything goes. So we've got our ball joint mounted on our control arm. We've used Loctite on there. And then what we did here with the rudder centered, got that ball joint, control arm and everything pushed out as far as possible. So it is in the middle of the pocket that it travels through right here. If we take that ball joint and suck it towards the pivot of the rudder, when this moves in this direction, it's going to hit the carbon arm here, which obviously we don't want to sand into. So that's what my black marks there are for. We've got this black mark right there, which is the line or position of our ball joint, and the other black mark is the blind nut location to center out the ball joint. So now what we'll do is we'll take off the rudder, and we want to make our wood piece that goes in here. So we're going to have a wood insert that gets high-soled in place. We're going to fill that whole thing with high-sol, make it nice and strong. There'll be a blind nut on the underside of the wood, and then our ball joint will screw right into that plywood, and it's going to be a nice solid connection. All right guys, so here is the final setup on the rudder. So I've got that piece of wood just resting in there just to check spacing and everything. You can see it's almost in line with the pivot line of the rudder surface, so that is going to work very well. So what I've done here is we've got some space underneath for a nice glob of high sol and to have our blind nut and everything mounted there. This can come back a little bit, but have to do a little bit of shaping still, but that is kind of what we're after there. So I'm going to play around with this a little bit more, maybe do a little bit more shaping, but so far so good. All right, so we've made lots of small little adjustments to this piece and spacing and everything. I wanted to have it inset enough that the bolt could go all the way in. So what we'll end up doing with this is getting it glued in place. But first thing we want to do is we want to treat the balsa with thin CA. So the balsa is not overly strong, but if you take thin CA and soak the balsa in thin CA, it'll suck it all up. And you can, usually it just kicks off by itself, which it's doing right now. And then what we'll do now is we're going to get our piece glued in. Now, it doesn't need to be super accurate because we've got some adjustment in this, this piece. and the arm length and everything, but we want it to be reasonably good. So we'll jam a whole bunch of high sol in there. Now there's a lot of extra reinforcing that we could do to this, such as when this is cured, we can put pins through the aircraft ply and put pins into the balsa. So there's lots of little things that we can do, but basically as long as we get it stuck in the right spot like that, we should be perfect. So what I'll do is make sure that we're happy with that. I think we are. Don't really have any spots that we can tack it in place with some CA, but I'll do a little bit right in this area here. Just to help hold it down. Yeah, that was enough. So now what I'll do is I'll take a gloved finger and we're just going to go through and we're going to fill all those gaps and everything with high sol. So we can paint this all black afterwards, and that'll be fine. Right now I think our bolt hole is open. There's a little bit of high sol in there. So what I'll end up doing is taking our screw while we wait for this, put a little bit of lubricant on there, and we will screw this guy down into the blind nut, and that's going to make sure that our blind nut doesn't get filled with high sol. So we'll do that, and then we'll come in and fill all this area up. All right, and there's the final shot of everything glued in place. So I'm not worried about how it looks right now. We can come back and clean that up afterwards if we need to, before we paint it black with the Dremel, but that is a nice solid connection. All right, and final step here, we finished our second vertical stab. So this one is done. Basically a match to the first one. The first one here is all cured. So we finished this guy up yesterday and it is perfection. So it's gonna work very nicely. Happy with how that all turned out. It's nice and solid. We'll end up painting that black as well too. We're just gonna wait for both of them to be ready. So this is the same, and we did of course install the other light as well too. Made our lens out of our epoxy material. So both of those vertical stabs are essentially complete. So great progress in video 2 on the Skymaster F14 hanging out in the background. Cool plane to be able to do one of these again, and it's turning out very well. Very happy so far. If you guys don't know this, we do live streams here from the shop on our other channel, which is called The Lighter Side of RC After Dark. If we do any giveaways from this channel, that's where we announce them. So I encourage you to go to that channel and subscribe. There is a link down below in the video description, and I'll also put it in the first comment of this video to our After Dark channel. It's fun. During the winter season, we do it every 2 weeks. Usually throughout the entire year, but obviously schedules get messed up a little bit, but usually Saturday evenings, and it's tons of fun. We do it for about an hour. We've got some guests in the shop, and we can see your comments if you're on the live at the same time. It's tons of fun. I love it. It's great. So yeah, good progress in this video, guys. Next video, we're going to continue on the tail section, moving our way forward. Thanks for watching, and we'll see you in the next video.